Hello everyone, and welcome to video 2 for chapter 7 of Stat 282 Online, which is now online. So you have hopefully read the notes between the last video and this video and gotten to this example here. So now you've already seen the formal definition of standardizing, and now we're going to actually standardize. So that's that z value you just saw 2 pages before. Okay, so right up here. Okay, so we have IQ scores can be modeled by a normal distribution with mean 100 and standard deviation 15. It is important that they tell us it is a normal distribution, as we will be soon moving into situations where we will first have to confirm that it is. Okay, so here the question is, what is the probability a randomly selected individual has an IQ score of 120 or greater? Okay, so I'm going to copy over to our whiteboard here what we have, and I can see my whiteboard here. Got exited out of. Okay, so we have a mean of 100 and a standard deviation of 15. We want to know the probability that a randomly selected person will score or have an IQ of 120 or greater. Okay, so I'm going to convert that for us into probability notation. So let's let x be the random variable for someone's IQ score. So then the question is actually asking, what is the probability that x is greater than or equal to 120? Okay, so our first step with answering these problems is going to be to standardize. Now, I will show you how to do this problem on the calculator, and you will realize that you may not need to always standardize, but this is the process that's been kind of done for decades because of technological limitations in the past. So we're still covering the idea here because it's very important. But of course in the future, you'll see that it might be simpler. So I'm going to calculate the z value. The z value is called the standardized value. Okay, so our formula for that is x minus mu over sigma. And I wish I had a touch screen here. It might be a little bit neater. Okay, so x is 120 minus mu, which is 100, over sigma, which is 15. Okay, and that gives us 20 over 15, or 4 over 3. Okay, so we want the probability that x is greater than or equal to 120, and that's fine, but usually, and this is how we've been solving these so far, the way we would solve this problem is first rewrite it with rewrite this with the 1 minus. And if you recall, that's called the complement rule. So I'm going to rewrite this as 1 minus. And when you do that, and we can do that because greater than or equal to or less than or equal to are complements of each other in general. So here, now I'm going to switch this to be less than or equal to. Now, something to note is I did not care whether or not I went less. Notice it's greater than or equal to, and now I said less than or equal to. When we dealt with discrete distributions, we had to be very careful about that equals to part. With continuous things, we actually don't care. And the reason for that is important. It's that for any continuous distribution, the probability that it equals an exact value is exactly 0. So it doesn't matter if we include the equals to or not. Okay, so now this part we can actually rewrite using our new standardized value. And this is how it actually happens. So here, now I replace the x with the z and replace the original number with our standardized value. Okay. So now this piece here is important. So this is what we can get from either a table or a calculator. So I'm going to switch over to PowerPoint. Okay, so we have z is less than or equal to 4/3. Okay, so this is where we see on this table, we can take 4/3 is 1.33, and there's some rounding there intentionally. Okay, so here we're going to use this table. Now in class we may or may not use the table if we ever in class again, but you should know how. So this is called a standard normal distribution table, and it only answers questions like less than or equal to. It will not answer questions if z is greater than or equal to. It will only answer if z is less than or equal to. So once you have the probability z is less than or equal to in this format that we just wrote out. So what I mean by format is in this way, less than or equal to here. Okay, now we can use the table. So what we do is we find 4/3 on the left-hand side and the top of this table. Okay, so here, 4/3 is 1.33. So you find the first number in the first decimal on the left side, where notice it says Z in the corner, and then you find the second decimal at the top, and you find the intersection of that row and column, and it says 0.9082. Okay, so switching back here, so then this entire thing is equal to 1 minus, you still need the 1 minus, 0.9082. Now doing this subtraction, we get, and I'm going to flip to the PowerPoint because I don't remember the exact number here. You get 0.0918. Okay, so back to the PowerPoint just so I want to reference the plot. So notice what we did here is what's shaded is before we took the complement. This tail on the right that's not shaded is the 1 minus area, and you can see that here. This area, this tail, because we want a greater than or equal to, is in the top tail there. Okay, so now we're going to do this in the calculator. Okay, so here I'm going to pull up the calculator. I'm going to turn my calculator on. All right, so here I'm going to go to distributions, so second variables, and I'm going to go down to, or actually don't have to go very far. We're looking for normal PDF, and did I do that right? I did that wrong. So we want normal CDF. And notice it has a lower and upper bound. So this is where I'm talking about the calculator we don't actually technically have to adjust. So we have two options right here. We can either work with our original mean and variance in our original x value of 120, or we can work with our standardized value. So to start, I want to work for our standardized. So when it says lower, it's talking about the lower side of this like area diagram here. So we're going to let it go all the way down to negative 1e99. That's essentially saying down to negative infinity or negative forever. Okay, upper, we're going to go down to, and we're going to put in the z value, so 4/3. Okay, hopefully it doesn't give me an error there, or we can put in 1.33. The mean and variance, because we're using a standardized value, we leave as 0, 1. Okay, so enter, and it gives us 0.9087. Now, that did not give us the final answer, and remember, that's because what we just calculated was just this piece here. We just calculated the probability z is less than or equal to 4/3. Okay, we could have calculated this. We're going to do this in a second, this piece directly, but this is the piece we just calculated. Okay, so to show you another way to do this, so then notice we got this number here, so we'd still have to do 1 minus. Okay, so now the other way we can do this. The original question asked, what is the probability that x is greater than or equal to 120? So I'm going to go back to distributions and normal CDF, which is the normal cumulative distribution function. Because we're answering questions about less than or equal to or greater than or equal to, that is why we use the CDF. Remember, that's when we use cumulative. The question asks us, what is the probability that x is greater than or equal to 120? So what I'm going to do is I'm going to set my new lower bound to be 120 because I want to look at 120 and bigger. My new upper bound, we're going up to infinity. We have no upper bound. So I do 1, and we're going to put in the e. The e's here are right above the comma, e, and then 99. Now, because I'm no longer working with a standardized value, I have to change the mean and variance to be, mean and standard deviation to be what we have, 115. And then enter. And notice we actually get the final answer directly here. Now, I was a little slightly off. So this error that we see, 0.0918 versus 0.0912, is because when we use a table, we are using an approximation. The table is an approximation. Notice we had to cut off the decimal place after 2 decimal places. So that's why we see a little bit of error there. So be aware that using the standardized method, you may be required to for 1. So you need to know how to do that. And for 2, I guess you need to show work sometimes. I mean, for your sake, if you do it that way, if you make a mistake, you'll be more likely to keep some of your points. Okay, so back to the PowerPoint here. So that concludes this video. Again, sorry it ran a little bit long. I'm going to try to keep these under 5 minutes, but this is probably the most important thing we're going to talk about in Chapter 7, so it ran a little long. Thanks. Have a good day.